Hi, this is Dr. Karthik, Faculty of Civil Engineering, SRMRI College for Engineering and Technology. I am going to give the short presentation about constituent materials. So in concrete, the three basic constituent materials are cement, aggregate, and water. In this presentation, I am going to give the short introduction about three basic constituent materials. In cement, we are going to see different types of cement and its chemical composition. In aggregate, what are the different classification of aggregate? In water, what is the quality of water for use in the concrete? So cement is a basic building material which will be used for different construction purposes. So there are different variety of cement. So based on the property of the cement, just we are going to adopt the specific cement in various construction purposes. The function of the cement is to bind the sand as well as the coarse aggregate together, as well as it has to fill the voids between the sand and coarse aggregate. So these are the different types of cements. The first one is ordinary Portland cement. In ordinary Portland cement, so there are three different grades: 33 grade, 43 grade, and 53 grade. Rapid hardening cement, extra rapid hardening cement, sulfur resistant cement, Portland slag cement, thick setting cement, super sulfated cement, color cement, ready cement, and IRS cement. Now just we are going to see the various type of cement one by one. So the first one is ordinary Portland cement. So this is the cement which will be used from the earlier stages. So based on the strength of the cement at 20 days, it was classified into 33 grade, 43 grade, as well as 53 grade. So the next one is rapid hardening cement. So this is very similar to ordinary Portland cement, but it develops the strength very rapidly. For example, so the ordinary Portland cement gains strength, particular strength at 7 days. The same strength can be achieved by rapid hardening cement at 3 days. So this particular cement is used for various road repair works. So the next one is extra rapid hardening cement. So this is superior to the rapid hardening cement. So this particular extra rapid hardening cement is obtained by adding calcium chloride content. So the important point, the addition of calcium chloride content should not exceed 2% to the weight of the cement. Next one is sulfate resisting cement. So normally this type of sulfate resisting cement is used in particular cases where there is more sulfate attack. So this cement is obtained by adding low C3A content as well as low C4AF content. C3A is tricalcium aluminate, C4AF is tetracalcium aluminoferrate. Next one is Portland slag cement. So this is the recently developed cement obtained by adding different types of slags like fly ash, GGBS, and different slag cement. So just by adding the slags to the particular cement, the properties such as fineness, setting time, soundness, and strength of the cement will be enhanced. Next one is quick setting cement. So this type of setting cement is obtained by reducing the gypsum content in the cement. Normally, this type of quick setting cement is used in underwater construction. So since it is very early, normally this type of cement is used in the underwater construction works. Next one is super sulfated cement. So this type of cement is normally used where the construction works having very high sulfate attack. So this cement is obtained by adding 80% of slag content and 10% of gypsum content and 5% of Portland cement clinker. This type of cement is normally used in foundation and marine constructions. Next one is colored cement. Usually the normal cement is grey in color. For aesthetic purpose, we will be using colored cement. So colored cement can be obtained by adding pigment content in such a way that the pigment content percentage ranges from 5 to 10%. So we can, by adding that colored pigment, we can able to get red cement, brown cement like that. The next one is ready set cement. Normally this ready set cement is used for repair works as well as patch repairs. So the last one is IRST special grade cement. So this type of cement is normally used in railway sleeper works. So this type of cement is obtained by adding high C3S content. As I have already mentioned, so this type of cement is normally used in the manufacture of concrete sleeper works. Next, just we are going to see the different test on the cement. So just they have classified the test on cement into field testing and lab testing. For minor construction works, just we have go for field testing. For major construction works, just we will go for laboratory testing. So in normal field testing, just they have opened the bag and the color of the cement should be in greenish gray color. And have to take some pinch of sand in the hand and it should be free from lumps and just you have to feel the smooth feeling. And suppose you have to take the pinch of sand in bucket of water, actually that cement should be flowed for some time before they have to sink. If it satisfies the above criteria, we have justified that the cement is of good quality. In laboratory testing, so there are different types of tests: fineness test, soundness test, setting time test, strength test, heat of hydration test, and chemical composition test. So there are different types of apparatus which will be used for conducting this laboratory test. For example, setting time test, we have to use WCAT apparatus. So next one is chemical composition of cement. So the main raw materials used for the cement is lime, silica, alumina, and iron oxide. So this lime, calcium oxide mainly constitutes about 60 to 70% of the cement, and silica contributes 25%. So this is the approximate composition of ordinary Portland cement. So this calcium oxide is 60 to 67%, and silica SiO2 is 70 to 25%, and alumina Al2O3 is 3 to 8%, and iron oxide Fe2O3 is 0.5 to 6%, and magnesium oxide is 0.1 to 4%, and alkalis like K2O, Na2O contributes 0.5 to 1%, and sulfates SO3 1.3 to 3%. So as I already mentioned, so this lime gives strength property to the concrete, uh, as well as silica also give strength to the concrete. And the quick setting property is mainly obtained by adding alumina in the particular cement, and the color properties obtained by the chemical composition of iron oxide as well as magnesia. So the calcium sulfate is mainly responsible for increasing the initial setting time of the cement. So these are the various functions which will be contributed by the different chemical composition of the cement. Next one is aggregate. So in aggregate, we will be mainly classifying fine aggregate as coarse aggregate. So fine aggregate is nothing but sand and coarse aggregate is nothing but jelly. So the main function of the aggregate is to give the bulk density to the concrete as well as durability to the concrete mix. So usually they have classified the aggregate based on the size and based on the shape. So we have first we will see the classification of the aggregate based on the size. So it is obtained by using IS Indian standard sieve. So you have to take the sieve and which are the material which will be passes through 4.75 ISMM sieve. So that aggregate will be called as the fine aggregate. So whatever the material which will be retained on 4.75 mm ISU, that aggregate will be called as the coarse aggregate. So the fine aggregate, it may be a natural sand or crushed stone sand, like that. So based on the IS code 383, we have classified the fine aggregate into different grades: grade 1, grade 2, grade 3, and grade 4. Coarse aggregate. So whatever the material, just will be retained on the 4.75 mm ISU, that will be called as the coarse aggregate. And the next one is classification of aggregate based on the shape. So based on the shape, the aggregates are classified into rounded aggregate, irregular aggregate, angular aggregate, Plaquemine, elongated aggregate. So rounded aggregate. So the main advantage of using rounded aggregate will be getting the minimum voids. So the minimum voids ranging from 30 to 33 percentage. But the main disadvantages of using rounded aggregate, the interlocking property between the aggregate will be very less. So it cannot be used for obtaining high strength quantity. So this is your image of the rounded aggregate. So next one is irregular aggregate. So in this, all the aggregate will be irregular in shape. So by using irregular aggregate, we can able to obtain the higher percentage of voids ranging from 35 to 38%. So since all the aggregates are irregular in shape, so it is also inadequate for obtaining high strength concrete. So this is the image for the irregular aggregate. So the next one is angular aggregate. So this is the normal type of aggregate which will be used in the manufacturing of the all types of concrete. So here the percentage of the voids ranging from 30 to 40%. So the main advantages of using angular aggregate is, so the interlocking properties between the particles will be very good, so that it can be able to create a good bond between the different materials. So by using this interlocking property, we can able to achieve a very good strength concrete. And the final one is Flakian elongated aggregate. So if the thickness of the aggregate is very less, that aggregate is said to be a flaky aggregate. Suppose if the length of the aggregate is more, that aggregate will be called as the elongated aggregate. See here, so the thickness is very less. So that aggregate will be called as a flaky aggregate. Here the length of the aggregate will be very more. That aggregate will be called as the elongated aggregate. So these are the different types of aggregate, classification of aggregate based on the shape. So the final constituent material in concrete is water. So water is a very important material because it involves with the chemical reaction with the cement. That is nothing but the hydration of the cement. In general, we can say that whichever the water is fit for drinking, so that water we can use it for the concrete. Technically speaking, if the pH value of the water lies between the range of 6 to 8, and if the water is free from organic matter, so that water will be used for the concreting works. So this is the table which describes the permissible different constituents in water. So the sodium and potassium carbonate and bicarbonate, the maximum permissible level is 1000 ppm, and chloride content 10,000 ppm, and sulfuric anhydride 3000 ppm, and the maximum chloride content in the water should be in 2% by weight, and the sodium content, it has to be very low, and the sodium sulfate, the maximum of 100 ppm, and the sodium hydroxide, it has to be maximum of 0.5% to the weight of the cement, and the salt content, it has to be maximum of 2000 ppm, and the total dissolved solute should be a maximum of 15,000 ppm, and the organic material is 3000 ppm. So ppm is nothing here but parts per million, and the pH value should be less than 6. And so this is the organic content. So the maximum permissible limit is 200 milligram per liter, and the inorganic material is 3000 milligram per liter, and the sulfate content should not exceed 400 milligram per liter, and the chloride content should not exceed 2000 milligram per liter, and the suspended content should not exceed 2000 milligram per liter. So this is the different IS standards for the water to be used in contracting. So this is the short introduction about the different constituent materials to be used in the concrete. Thank you.